Now, get ready to see how we calculate the derivative of y equal ln of x. Now, we've already done its inverse. We know that d dx of e to the x is equal to e to the x. Now we're going to calculate the derivative of y equal ln of x. And the way we're going to do this is we're going to write down what y equal ln of x means. It means that x is equal to e to the y, because you recall that ln of x is really the logarithm to the base e. So saying that y equals ln of x means that x equal e to the y. Now what we're going to do is take d dx of both sides of this equation. D dx of x equal d dx of e to the y. D dx of x is just 1. D dx of e to the y is, first of all, take the derivative of e to the y with respect to y, which is just e to the y, and multiply by dy dx. Chain rule again. Now notice we can calculate dy dx equal 1 over e to the y. But recall that e to the y is equal to x, so dy dx is just 1 over x. So we now have a very important result, that d dx of ln of x is just simply 1 over x. And you'll see on the logarithmic table, or the derivative table that you were given out, that this result is on that table. Now another derivative that's on that table is a logarithm of x to the base b, the derivative of it. So what is dy dx when y is equal to log of x to the base b? Well, remember that we can write log of x to the base b as log ln of x divided by ln of b. That's just the change of base formula that we just showed you on a previous slide. If you want to take the log of x to the base b, we can take ln of x and then divide it by ln of b. Now, dy dx, since ln of b is just a constant, it's just going to be 1 over ln of b times d dx of ln of x. Well, d dx of ln of x is 1 over x, so the result is 1 over ln of b times x. So, very important result is that d dx of log of x to the base b is equal to 1 over ln of b times x. Now, we can work a couple of problems here. Let's take, first of all, a d dx of ln of 2x. Here we'll use the chain rule. The derivative of ln x is going to be 1 over 2x times d dx of 2x. That's a chain rule. That's going to be 2 over 2x is equal to 1 over x. And now b, if we want to take d dx of ln of x squared plus 3, notice this is not just plain old ln of x, it's the blob is equal to x squared plus 3. So we take the derivative with respect to the blob, and it's 1 over x squared plus 3 times d dx of x squared plus 3, which is 2x. So we get 2x over x squared plus 3. Now we're going to calculate the derivative of a to the x. Since the base is not e, it's not simply a to the x. But what we have to do to show this is that we need to write a to the x is equal to e to the ln of a to the x. Let's make this a little clearer. A to the x, excuse me just a second, a to the x can be written as e to the ln of a to the x. Remember, e to the ln of anything is anything, and so we can write e to the ln of a to the x as equal to e to the x ln of a. This makes use of the fact that ln of a to a power is equal to that power times ln of a. So now we can say that d dx of a to the x is equal to d dx of e to the x ln of a. And that is just going to be e to the x ln of a times d dx of x ln of a, which is just ln of a. Now you won't have to prove this on a test, but you will have to be able to use this result to calculate a derivative of a to the x. So d dx of a to the x is equal to a to the x, almost the same as e to the x, but you have to multiply it by ln of a. Now we're going to study one last topic here, and it's showing how to take the logarithm of some fairly complicated functions. But if you first of all take the natural logarithm of the function and use the properties of logarithms, you may be able to write down the derivative very easily. Now look at this function here. Y equal x squared plus 1 times x plus 3 to the 1/2 power, all divided by x minus 1. Now if you had to use our rules for this, you would have to use the quotient rule, the product rule, and the chain rule. To get away from doing that, you see we can just take ln of both sides of the equation and write that ln of y is ln of this expression here. And notice this is a product of some functions divided by x minus 1. So we can write that as ln first of all, of the numerator minus ln of the denominator. That was one of the rules we just looked at. Remember, the logarithm of a quotient is equal to the logarithm of the numerator minus the logarithm of the denominator. Now the logarithm of this product is equal to the sum of the logarithms of each individual factor. That would be ln of x squared plus 1 times ln of x plus 3 to the 1/2 power minus ln of x minus 1. Now we simply write down for ln of x squared plus 1, just rewrite the expression. But the ln of x plus 3 to the power 1/2 can be written as 1/2 ln of x plus 3. And then, of course, we have minus ln of x minus 1. Now, look at what we have. We have 3, the derivative we have to take of ln of x squared plus 1 plus 1/2 ln of x plus 3 minus ln of x minus 1. If we take the derivatives of both sides, we'll then take the derivative of ln of y, which is just going to be taking the derivative with respect to y as 1 over y times dy dx, the chain rule. So the derivative of the left-hand side is what I circle here. The derivative of each of these parts now, the derivative of ln of x squared plus 1 is going to be just 1 over x squared plus 1 times 2x, which is the derivative of the u function. And then the derivative of 1/2 ln of x plus 3 is going to be 1/2 times 1 over x plus 3. And then finally, the derivative of ln of x minus 1 is 1 over x minus 1. So now, look very carefully at what we have here. We have 1 over y dy dx. And to get dy dx, we just simply need to multiply both sides by y. Well, y is just simply what we've already written down. So we'll rewrite what we said was 1 over y times dy dx. Solving for y, we multiply both sides by y, and we get dy dx is equal to y times the expression we had for the derivative of the right-hand side. And since we know what y is, we just write it down from the previous page. And indeed, this is a very complicated answer, but it was easy to take the derivative and just simply to rewrite the original equation down. And so that's it for logarithmic differentiation.